the radiation that gets emitted by alpha, beta, and gamma decay is called ionizing radiation. It's called ionizing radiation because it actually creates ions. Now, ions are charged atoms, and you can imagine within a cell or an organism, if ions are being created within cells, what it does is create unwanted chemical reactions within the cell. And this can have a whole series of different negative health effects. And partly that depends on the dose, so how much, and also what part of the organism is irradiated or exposed to the radiation. There's short-term or acute effects, and there's chronic or long-term effects. Firstly, with high doses, we have the short-term effects. So, being exposed to a high dose of radiation can cause cell death. So it creates ions within the cell, causing unwanted chemical reactions that actually cause cells to die. Now, so in a local area, for example on the skin or in the tissue, if a local part has been exposed, it actually causes radiation burns. If a large number of cells throughout the organism are killed by the ionizing radiation, then systemically or across the whole body, the organism feels very, very sick. And this is called radiation sickness. And this can actually lead to death of the organism. A Russian spy or an ex-Russian spy was assassinated with polonium-210, a radioisotope. Also, radiation can have more long-term effects as well. Exposure to radiation can affect the DNA within the nucleus of cells. It actually alters the DNA. Now, if that happens in body cells, say skin cells, cells of the lungs or different organs of the body, it can actually turn on cancer genes. And of course, ultimately, if the cancer genes are turned on, it's going to lead to cancer. So exposure to ionizing radiation can cause cancer. Now, if the cells that get irradiated are the sex cells, so sperm and eggs, or the gonads that actually produce the sperms and the eggs, so what we call the sex cells, if mutations occur to the DNA of those, then the offspring can have birth defects. So there's a whole series of different negative health effects from ionizing radiation. Now, different radiation has different properties in terms of the amount of danger from them. Different radiation has different properties, and that affects how dangerous these different types of radiation are. So we've got alpha, beta, and gamma decay. Alpha particles are the heavy ones, aren't they? They're 2 protons and 2 neutrons. So they're heavy. They're actually got a very high ionizing potential. So they're actually very, very dangerous. However, because they are heavy and slow, they have low penetration. They can't even get through our skin. Alpha decay is not dangerous unless it's ingested, or so in other words swallowed, or breathed in, like with that Russian. So let's do gamma. Gamma is actually not particles at all. It's just radiation. It's got a lower ionizing potential. However, it can actually penetrate through lead. So it's actually stopped by thick lead or concrete. So whilst gamma radiation doesn't have the same ionizing potential, it can go straight into an organism without problems. So that is really quite dangerous. Beta is somewhere in between. It's it's obviously much lighter than an alpha particle, and the ionizing potential is somewhere in between, and it gets stopped by 1 millimeter of aluminium. And finally, alpha is actually stopped by skin. Okay, so understanding the properties of the different types of radiation gives us an idea of how dangerous they are